July 2025. Astronomers expected nothing more than another icy wanderer crossing the night sky. Instead, what they found was something that defied every known rule of celestial behavior. The object, soon named 3I, Atlas, wasn't behaving like any comet ever seen. Its tail wasn't trailing away from the sun as physics dictates. It was pointing toward it. That impossible plume created a faint but measurable thrust, as if the object were propelling itself inward, using the sun as a destination, not a force to escape. From the moment it was detected, it was clear, this was no ordinary visitor. Discovery. On July 1, 2025, the Atlas Observatory in Chile flagged a fast-moving anomaly sweeping through the constellations of Sagittarius. Initial data revealed a speed of nearly 135,000 miles per hour, far beyond what a normal comet could achieve under solar gravity. Follow-up measurements confirmed what every astronomer dreaded and hoped for. Its trajectory was hyperbolic, an open curve, the unmistakable mark of something from outside our solar system. Within hours, observatories across the world turned their eyes toward the new arrival. It was officially named 3I, Atlas, the third known interstellar object ever detected after Oumuamua and Borisov. But even among those legendary anomalies, this one stood apart. The data hinted at precision, a course almost perfectly aligned with the ecliptic plane, threading between Mars and Venus before vanishing into the sun's glare. No random rock from the stars should travel that path. The sunward jet. By July 21, the Hubble Space Telescope captured the first clear images. What it revealed stunned every analyst watching the feed. 3I, Atlas displayed a narrow, focused jet of material streaming directly toward the sun. Normally, a comet's tail points away, pushed by solar wind and radiation pressure. Yet this one seemed to do the opposite, a controlled outflow aimed with impossible steadiness. Every test for image artifacts failed. The pattern held firm across all exposures and filters. Astrometric teams ran new orbital calculations and found something even stranger. The object's path was subtly bending, accelerating against gravitational expectations. The extra force measured at 4 × 10⁷ meters per second squared, tiny but persistent, perfectly aligned with that sunward jet. If this were normal outgassing, the object's motion should wobble and drift. Instead, it was smooth, deliberate, unwavering. Whatever was driving that thrust, it wasn't random physics. The impossible numbers at the University of Maryland, a team of jet propulsion modelers ran the math. To generate that level of acceleration naturally, 3I, Atlas would need to eject over 300,000 kilograms of gas and dust per second, a figure beyond reason. In reality, spectral analysis showed barely a single kilogram per second leaving its surface. The difference, a factor of 10,000, meant one thing: the energy didn't add up. For a comet, that was the ultimate red flag. The chemistry when the James Webb Space Telescope locked on, its infrared spectrograph told another story. Carbon dioxide dominated, nearly 8 times more abundant than water, an inversion of the usual cometary mix. Even stranger, Webb detected nickel without iron. On Earth and in meteorites, those two metals are almost inseparable twins. Finding one without the other defied every geological and astrophysical precedent. The data was checked, recalibrated, and rechecked again. No errors. No contamination. The chemistry of 3I, Atlas was simply alien. By mid-August 2025, the mystery surrounding 3I, Atlas had already grown beyond simple astronomy. This was no ordinary interstellar visitor. Its motion, its chemistry, and its persistence all hinted at something calculated, something that seemed to follow its own design. At the Harvard-Smithsonian Center for Astrophysics, orbital modelers began running millions of simulations. Their goal? To determine just how likely it was for a random interstellar object to appear on such a precise path. The results stunned them. The odds that a body from beyond the solar system would arrive just 5 degrees off the ecliptic plane, weaving near Mars, Venus, and Jupiter in near-perfect alignment, were less than 1%. Almost everything about 3I Atlas defied probability. Coincidence, perhaps. But if it was random, then it was the most elegant randomness the universe had ever shown. Its rotation rhythm, measured through subtle light flickers, remained constant down to fractions of a second. Its plume stayed perfectly directed toward the sun, a steady, deliberate jet of energy that refused to fade. And every model showed the same acceleration vector, precise, consistent, impossible to dismiss as mere chance. As data accumulated, comparisons to the infamous Oumuamua resurfaced. That earlier interstellar traveler, discovered in 2017, had moved through our solar system without a visible tail, yet still accelerated in ways gravity couldn't explain. But 3I Atlas was different. It didn't hide. It glowed, burned, and turned its jet directly toward the sun as if performing for anyone capable of watching. Where? Oumuamua whispered questions, 3I Atlas shouted them. The blackout. By late October, a new challenge approached: solar conjunction. During this period, the object would slip behind the sun from Earth's perspective, vanishing into solar glare for nearly 6 weeks. No telescope, not Hubble, not Webb, not even deep space probes, could track it. Every observatory raced to collect final images, desperate for data before the inevitable silence. Then, on October 30, 2025, it disappeared. The last frames showed its luminous jet bending slightly, the brightness fluctuating in rhythmic pulses, like a heartbeat fading into sunlight. For the world's astronomers, the blackout was torture. No signals. No telemetry. No new coordinates. If 3I Atlas changed speed, rotated, or altered direction during that hidden passage, no one would know until it re-emerged on the other side of the sun in December. Inside NASA and ESA, encrypted channels buzzed. Contingency plans were drawn up. What if it didn't reappear where predictions said it should? What if it was gone altogether? Even private observatories and citizen astronomers joined the waiting effort, preparing for the moment the object would step back into view, or fail to. Theories and fears. In the absence of new data, imagination filled the vacuum. Some scientists turned to theoretical physics, proposing that 3I Atlas might be driven by solar reactive plasma sails, thin, quantum-layered materials that could transform light into propulsion. Others speculated it was an ancient autonomous probe, a so-called Bracewell messenger, designed to seek out intelligent life. It would travel the stars, waiting silently until it detected a civilization capable of noticing it. But not everyone viewed it with optimism. A darker idea began to take root. What if it wasn't a probe, but wreckage, a fragment of technology from a war fought between civilizations long gone? Its propulsion system damaged, its guidance routines fractured, it could simply be following ancient instructions, repeating motions it no longer understood. Even more unsettling, what if the plume itself, that focused jet of light, was not exhaust, but communication? A form of signaling we simply hadn't yet learned to read. From forums to think tanks, one conclusion kept echoing: nature alone struggles to explain this. The waiting game. As the weeks of silence dragged on, the world waited. If, when 3I Atlas reappears in December 2025, its path deviates even slightly beyond what gravity predicts, it will mark a turning point, not just in astronomy, but in human history. The question will shift from what is it to who made it. Some predict it will continue on its hyperbolic path and drift into the dark, leaving only data and speculation behind. Others believe it may decelerate, loop back, or even signal again, proof that intelligence has touched the edges of our solar system. But for now, all anyone can do is wait. Every telescope is ready. Every sensor tuned. Every mind braced for an answer that could change everything. Because whatever 3i Atlas truly is, comet, craft, or something between, it has already forced humanity to confront a truth older than science itself. That perhaps, somewhere in the depths of space, we are not alone. And as the object prepares to emerge from behind the sun, a single thought lingers across every control room, every observatory, every quiet stargazer looking up into the night. What if it's looking back?